Pryia, it's Math Wednesdays with me, Pryia, with the Learning Liaisons. I'm actually coming to you from Florida today. I know most of the time I'm in New York and I'm on a little mini vacation back home in Florida. So it's kind of cool to say hi to all my Florida people, whoever's here in Florida with us, well, me. And then today's August 17th, 2022. And like always, let's go ahead and do some math today. All right, so problem 1 says a parallelogram has an area of 180 feet squared. A new parallelogram is created by dilating the original by a factor of 3. What is the new parallelogram? Oh, the area of the new parallelogram. I was like, wait, the question seems to be missing something. It's not. It's just my reading. So first things first, we have to figure out what we need, right? So it says a parallelogram has an area of 180 feet squared. So that is definitely information that we need. They tell us that the new parallelogram is dilated by a factor of 3. So you have to know what that means in order to answer the question. So what does dilation mean? What does it mean to dilate in math? And I recall going over dilating with you guys before. So dilate like your eyes. I spelled it really wrong. Let's try that again. So dilate like your eyes, they get larger and smaller, right? So same thing here, it's going to enlarge or shrink by the scale factor. So most of you keep asking, like, how do I know if I have to multiply? How do I know when I divide? Things like that. Well, the thing about dilation is you're always going to multiply. And it's going to get larger because you're going to multiply by a whole number. And it's going to get smaller because you're going to multiply by a fraction. Right? So anytime you dilate, you're going to multiply. That's something to always keep in mind. So here we know that our current parallelogram has an area of 180 feet squared. That feet squared, if they didn't tell us area, is also a good keynote to know because squared units always tells us area, right? And if we had a cubed unit, so feet cubed, we would have a volume situation. So here, without having to know area, we automatically knew that it was the area of whatever the shape is that they provided to us. So let's go ahead and do the problem. So it says that it's dilated by a factor of 3. So we're going to take 180, multiply by 3, and we're going to get 540 square feet or feet squared. And that is actually the area of the new parallelogram. All right, any questions? Doesn't seem so bad, right? Okay. Like always, if you have questions about a problem, once I've moved on, I will definitely go back, but after I finish the problem that I'm on right now, all right? All right, problem number 2, here we go. So Miss V gave an algebra test, and the scores are shown below, except for one student who was absent. So if Miss V wants to have a class average of 77 on the exam, what does the absent student need to score on the test? And they're telling us that we need to round to the nearest whole number. So that's always good to know, because if we get a decimal, we notice that our answers are all in whole numbers, so we have to round up or stay where we are based on what our decimals give us, right? Well, let's read back the problem. It tells us that the scores here are of all except one student who was absent. So what we automatically know is that we have another number. Well, we're going to need another number because that's the student that was missing. But it does tell us what they want. Miss V wants a class average of 77 on the exam. So when I hear average, what's the first thing that comes to mind? Anyone want to tell me what they think of when they hear the word average? Average is the same as saying mean, right? So when we're solving for the mean, how are we doing this? So the mean or the average, I'll put A or M, is equal to the sum of all the numbers divided by the amount of numbers. So if I know that the average or the mean is the sum of everything divided by however many numbers I have, I know that I can do this problem. They told us what the average is. We know the average is what? The average is 77. So there's no hidden agenda here. They've already given us that part. So I'm going to take my words and put as many numbers in as I know. So right now, I know that my average is 77. So I'm going to say 77 is equal to what? I'm going to do the sum of all the numbers. So before I get started, I'm going to back up a little bit and I'm going to do the sum of all of these numbers. So add 92, 72, 76, 94, 83, 82, 84, 73, and 71. Put it all in your calculator or write it all out. Give us the sum. The sum should be 727. But don't forget, that's of the students that took the exam. We're still missing that X that we wrote, that student that was absent. So we're going to have 727 plus X, that missing student, right? Because we need to know what they need on the test in order to have a total of 77 as an average. So now let's go ahead and go back to those words that we wrote out earlier, and let's put our numbers in there. So I know the average or the mean, it's 77. I now know the sum is 727 for the students that took the exam, plus X for the student that missed the exam. And now I'm going to divide by the total, that means everybody, including the absent student, divide by that many numbers. So I'm going to count and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to divide by 10 because there are 10 students. All right, now the thing that we need to do is solve for this lovely X over here. So first things first, I don't like that denominator of 10, so I'm going to multiply both sides by 10. By multiplying by 10, it's the opposite operation. So the opposite of division is multiplication. Multiply both sides, and you get 770 is equal to 727 plus X. I'm going to move the problem over here so I have enough space. All right, now last thing to do is to get that X by itself. So I'm going to have to subtract both sides by 727. When I subtract by 727, I get that X is equal to 43. If the student scored a 43 on the exam, that means the class average would be 77. And that is what you need. That is what the student needs, not what you need. That's what the student needs in order to have that class average that Ms. V was looking for. All right, and if you don't believe me, what you can do is check your work. And you check your work by doing 727, add your 43, divide it by all the people, and see if it gives you 77. All right? Any questions? Go ahead and put it in the chat, and once I'm finished the next problem, we'll come back to them. All right, problem number 3. I do my little work, so I try to keep my papers together. So problem 3 says the average lifespan of a catfish is 60 years with a standard deviation of 3 years. And it says, which of the following is the best interpretation regarding the previous statement? So the statement here that I'm highlighting in green is the statement that we're using. So what do we know? We know that the average lifespan of a catfish is 60 years. So right now we know average 60 years. And then it tells us the standard deviation is 3 years. I'm going to name that SD for standard deviation, 3 years. All right, so now that we have all of this information, let's go through those answer choices and let's figure out what makes no sense at all. And let's try to be left with some problems that give us a little bit more insight on what's going on to help us solve, right? So here we have the median lifespan of a catfish is 65 years. Can we actually find the median based on just the average and the standard deviation? No, no, no. We need a little bit more than just a standard deviation and an average here. So it says most catfish live to be older than 57. Okay, we don't really know what's going on here. Most catfish live to be between 60 and 66. Okay, here we go again with the not sure. And then the longest living catfish lived to be 72 years. Well, I don't know what the catfish lives to be. I have no idea. They have given me no information on that. They just told me that the standard deviation is 3 years and the average is 60. They said nothing about the guy who lived the longest. So D is definitely out. So now we're kind of left with B and C. So now it really goes back to what do you know about average and standard deviation? There's one thing that really should be coming to mind, and it's this really cool thing that kind of looks like my hand motion. It's a lovely bell curve. Please bear with me as I am not Picasso, but I do try my best to get through these. So here we go. We have a bell curve. Not too bad. All right, it's not perfect, but that's all we need. We don't have to be perfect. We're all humans. So what is the number that goes in the middle? It's definitely not the median. It is actually the average. And then once we move 1 standard deviation, 2 standard deviations, and 3 standard deviations. That means we're going to add 3 and subtract 3 all at the same time. So the first standard deviation plus 3 is going to be 63. Then we're going to do another standard deviation to be 66, and the last guy is going to be 69. And then to go backwards, we're going to do 57, 54, and 51. Okay, so we have our first standard deviation, second standard deviation, and third standard deviation. So here's the thing that you need to know. You actually need to know the percentage between those standard deviations. I'm going to give them to you. So the first one here is actually 34.1. That does not look like a point. Let's try that again. So this one's also going to be 34.1. Then we have 13.6. Then we have 2.1. And we have 0.1. And it repeats on the other side. So I'm going to write those in. And while I'm writing those in, something that you should be thinking about is going ahead and like adding these percentages to figure out which one of these answers is a better answer. So it's saying that most catfish live to be older than 57. So 57 is here. It's telling me to take into account all of those numbers, right? So I actually have 34.1 plus 34.1 plus 13.6 plus 2.1 plus 0.1. And then I realized I did not do the math for that. And I have C, which says just 60 to 66, which is 34.1 plus 13.6 plus 2.1. Oh, well, there's a reason I didn't do the math, because it's a little obvious that more numbers are going to give you a larger percentage, right? So more fish lived to be older than 57 years of age. That is the larger number, so we have the most amount of fish that live to be there. Ta-da! Okay, I see in the chat a lot of stuff going on. Yes, the Learning Liaison does offer private tutoring. It is definitely on our website. It is something that I suggest you look into, and it's based on availability. Where do I get the decimals? Okay, so this is kind of something that you have to look up, right? It's knowledge to know that the first standard deviation is 68.2%, And if you break that into two pieces, because it goes from the middle to the left and the right, you break 68.2 into 2 and you get 34.1. And then the second standard deviation, here, let me write some steps so I'm not just speaking out loud. Okay, so the first standard deviation is 68.2. Then we have the second deviation, that's the green one, and that is 95.6. And this is information you can get from textbooks, you can get online. This is not something that I just pulled from the sky. Somebody else figured this out for us, and it's just information that I'm using. And then the third standard deviation is actually going to be 99.7. So in order to answer the question, what I did was I broke all of those standard deviations into two, because the first standard deviation counts for the left and the right side. So that's the 57 and the 63. Well, I need to break it up into two parts because I need to figure out each individual piece in order to help me, right? So when I break them up into the two parts, that's where I'm getting the 34.1, 13.6, 2.1, and 0.1. And that's just things to know. So this is something that I suggest you go ahead and write out, put it on a note card so you know it. I was able to assume that it was a normal distribution because they didn't tell me anything outside of that. So I went ahead and went on a limb, right? They didn't say that it skewed left or it skewed right or anything like that. So I went ahead and just assumed that it was a normal distribution. No, it's not mentioned in the problem, but sometimes we have to take those leaps of faith and go ahead and go with it. If I didn't do a normal distribution, I don't see another way to solve the problem. And if I am wrong, I am more than welcome to take anybody up on a different way to solve the problem. These are great questions. Keep them coming. Anything else? I would like to say yes to that theorem. However, I have not looked it up in a while, so I would not be able to answer that right this second. I do suggest go ahead and emailing us, and I will definitely get back to you on the best method of solving the problem if it was skewed. Promise you on that. Actually, I'm going to take a quick picture so I don't forget. All right, great question. Keep them coming. I love being challenged. All right, number 4, Amy was saying that you guys want to know more about the quotient rules and the chain rules. So here are some problems for you, right? Problem 4 gives us this lovely quotient, and all they do is tell us to do this. Well, you have to know what this is in order to be able to solve the problem, right? And sometimes by just staring at the problem, it doesn't really give you any information. So you have to know some background information. You have to know that this guy right here is a derivative. And in order to solve, you have to use the rules of derivatives in order to be able to be successful with this problem. And now my screen is stuck. Okay. So we have to take the derivative of that first function. Does anybody know what that rule is? It's definitely a quotient rule. All right, I'm going to go ahead and write out the quotient rule. It's going to be g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. Okay, but now you guys are staring at it and you're like, well, I don't know what f of x is and I don't know what g of x is. And you're just writing all of these random letters and you're telling us to do stuff and you're making us go crazy. I promise I'll tell you, nothing to be worried about. Top guy, always f of x. Bottom guy, always g of x. Don't complicate it, I promise. So we're going to write f of x and g of x. I always like to take the derivatives first and then plug everything in. I try not to make it more complicated by trying to solve it and plug it in all at the same time. So that's just my little way of doing it. If you don't like it, you're more than welcome to just plug it in and do it however you would like, but you still have to take the derivatives of these things, right? So let's start with our f of x. Our f of x is just the numerator. That's going to be n cubed plus 2x. I'm going to take the derivative. I notice that you guys can't see that, so I'm going to rewrite that. Okay, my f of x, all right, there we go, is x cubed plus 2x. All right, so to take the derivative, I'm going to use the power rule, right? So I'm going to take the 3 and put it in the front, and then I'm going to subtract that 3 in the exponent by 1, and I'm going to get 3x squared. And I'm going to do the same with the x. I'm going to take the imaginary 1, multiply it by that 2, and get 2, and I'm going to subtract 1 by 1 and get 0, so I have no x. So I have my f of x and my f prime of x. All right, now let's go ahead and do our denominator, which is going to be our g of x, and that's going to be x minus 1. All right, so I'm going to use power rule again. Here we go. Anything that has an x, I'm going to take my number and multiply in the front, and then subtract the exponent by 1. So my 1 to that x, so I have 1x, and then 1 minus 1 is 0, so I just have 1. And that negative 1 doesn't have anything to take a derivative of, so it kind of just goes away. It is not something we have to worry about. Now, what I have to do is plug in what I know. So I'm going to start with my g of x, and my g of x is x minus 1. I'm going to multiply that by my f prime of x, and that's going to be 3x squared plus 2. And then I'm going to keep my subtraction sign because there's a big subtraction sign there. And I'm going to do f of x, which is x cubed minus 2x. And then I'm going to multiply that by my g prime of x, which is 1. And I'm going to put that all over my gx squared, which is x minus 1 squared. So before I start tackling the problem, is anybody else having a problem with the screen being blurry? Before I go ahead and tackle the problem, I'm going to look at my answer choices. Based on my answer choices, it's going to help me understand where I need to go. I look at my answer choices and I notice that x minus 1 squared has not been expanded. So guess what this girl's going to do? Not expand it. And then I also noticed that b doesn't have a denominator, so it's probably not going to be an answer choice that we're going to choose. And then everybody else kind of looks like they're expanded at the top, so I actually have to do the work in the numerator. Not too bad. So let's go ahead and get started. The numerator tells us that we have to FOIL or multiply the first two set of parentheses and then figure out what's going on after the minus sign. So my method of FOILing is taking the first term and giving it to everybody in the second set of parentheses, and then taking the second term and giving that out. So I'll do x times 3x squared, and I'll get 3x cubed. And then I'll do x times 2x plus 2x. Then I'm going to do negative 1 times 3x squared and get a negative 3x squared. And then I'm going to do negative 1 times 2 to get a negative 1. And then the cool thing about that 1 is you don't have to multiply anything by it, so we just leave that there. It just goes away. And then that negative needs to be distributed. So I will do, oh, I wrote that wrong. Wait, I made a mistake. Okay, I'm going to write it in black. I wrote minus 2x, and that's supposed to be a plus 2x. All right, I fixed it. Human error, and it happens all the time. I greatly apologize. So now we're going to do the second part, and we're going to distribute that negative to those two pieces, right? So we're going to have negative x cubed minus 2x. Make sure you fix that 2x. It's supposed to be a plus 2x. It was a big boo-boo on my half. And we're going to keep that all over x minus 1 squared. So now we're going to combine like terms, nothing too fancy to worry about here. I know we all know how to do it. Here's a 3x cubed, and here's a negative x cubed. So what happens there? We have 1 less cubed, right? So we'll have 2x cubed. Then we have a 2x and a 2x, and that's a plus and a minus, so those guys go away. Then we have a negative 3x squared. We keep that guy there because there's nobody else to put him with, and we keep the negative 1, and we keep it all over x minus 1 squared. And we hope that one of my answer choices look like that. And
Okay, I'm still here. I have no idea what happened. I came back. Yes, I was also talking about another mistake that I made, and it's 100% me. So hold on, I'm coming right back. I'm sharing my screen with you guys. Give me 1 second. We might go over a little bit today just because I completely, hey, it disappeared. Okay, we're back to normal. All right. So yes, I made 2 mistakes. How dare I? I know. I was just talking about this. And as I'm doing the math, I'm realizing that my numbers don't make any sense. And it's because I did the problem before. But I have this really horrible thing about speaking and not writing the same thing. That is a 2. Okay, so I fixed it. I fixed both of them. I fixed all the mistakes, I promise. So that means that I have to go fix the other mistake when we are adding them together, because we have just the negative 2 hanging around by itself, which means that I actually did not do the answers right still. Okay, so this problem seems to be a little doozy for me, but we're going to go with C, and we're going to make that negative 3x squared. We have a negative 2 there. It's the closest to the answer choice, which means I'm just the crazy person that can't do the math today. I greatly apologize. All right, so I'm going to box this, put answer next to it, and that I'm for sure is the answer. Now that I made all these mistakes, any questions? All right, let's keep going. So here's another problem, and it just gives us the stuff. So we have to figure out what we have to do with the stuffs, right? So I'm looking at it, and that d of dx kind of gives me a hint, right? It kind of tells me that I'm definitely going to be taking the derivative. And I'm going to be taking the derivative sine 3x squared plus x. Well, the thing about this is we can't just take the derivative and say that we have the derivative of sine is cosine, and then take the derivative of the inside and get 6x plus 1. That's just not going to be a thing. There's a rule that goes with this, and this is going to be the chain rule. All right, so the chain rule tells us that we start with this f of g of x, and we're going to do the prime of f, so f prime times whatever the g of x is, and we're going to multiply that by g prime. And it'll make sense what we do once we do it, I promise. All right, here we go. Let's get started. So I'm going to go ahead and name these different pieces, right? So I'm going to have my f of x, which is going to be sine, just sine, nothing else. And I'm going to have my g of x, which is 3x squared plus x. All right, now that we have 3x squared plus x, that's our g of x, we have sine, that's our f of x. Go ahead and take your derivatives, make it a little bit easier for yourself. The derivative of sine is going to be cosine, so my f prime is cosine, and my g prime of x is going to be 6x plus 1. So I'm going to take the 2 and multiply by the 3 and get a 6. Make sure you subtract your exponent by 1, so you'll have 1 instead of 2. And then the same thing goes for the x. You take that imaginary 1 and multiply it in the front to get your 1, and then you subtract that 1 by 1 and you get 0. So now I'm going to plug it in based on what I know over here. I'm going to have f prime, which is cosine, and put that times g of x, which is 3x squared plus x. Then I'm going to multiply it by my g prime of x, which is 6x plus 1. Then I'm going to look for answer choices that look like that. 3x is not what we multiply on the outside. This looks like a great contender. C is missing the 3x squared plus x. And this is close, but no cigars. It's missing the plus 1. So our answer here is 100% going to be B. All right, any questions? All right, I'm gonna keep going. Okay, now we have problem 6. And problem 6 is giving us our f of x, which is log of x, and then they're just simply telling us to find the derivative of it. So f prime of x. So we're going to derive again, so we're going to take the derivative. Derivative, lots of derivatives. Okay, so the thing here is you have to know what you're doing. It's one of those special cases, right? Log of x, you have to know the rule. If you know the rule, you know how to do this. I'm going to write the rule out. The rule tells us this. When we're taking the derivative of a log, remember we generally have an a, which is the base, right? And that then tells us the derivative part, and that will be 1 over x times ln of whatever a is. Put that in blue and be consistent. Does anybody by chance know what a is if a is not visible? If you actually don't see a number, what should a be? It's always going to be 10. All right, so here they didn't give us an actual a, they didn't give us a number, they just told us log of x. So we're going to know that we're supposed to put 10 for a. So I'm going to rewrite f of x, and we're going to have log 10 of x. Now I'm going to go ahead and do the derivative based on what I know on the rule of the derivative of that. And I'm going to get 1 over going to be f prime of x, 1 over x times ln, and then my a is 10, so I'm going to put 10. So it's not a, it's not b, and it's not d, so it's going to be c. And this is one, if you know, you know, and if you don't, you can't really fake it. This one's not a fake it till you make it kind of question. This one is a you have to know in order to be able to solve kind of question. So I love going over things like this, just refreshing your memories and keeping you guys up to date with just those little special cases, right? All right, any questions, you know what to do, put it in the chat and I will answer it. Okay, we have problem number 7. Here's another derivative. You guys are probably tired of derivatives. Derivatives actually make me happy, so I'm not too worried about them. So here is a lovely sine problem again. And we know it's derivative based on the front, right? And can somebody tell me what type of derivative rule we're going to use in order to solve? It's the chain rule, right? It's the rule that we used 2 problems ago, so I'm going to rewrite it again just to refresh your memory. It's going to be f prime of g of x multiplied by g prime of x. All right, so here we go. Let's write out what we know. We know f of x is sine, so we know that f prime of x is going to be cosine. And we also know that this part here is our g of x. So our g of x is 3x plus 9. So that means our g prime of x is going to be 3. That's it. Just 3. I didn't say that with a period at the end. It's just 3 because I'm going to take my 1 exponent and multiply it by my 3. And remember, I have that 1 minus 1 to give me 0 x's. So I'm going to just have 3. The 9 doesn't have an x, so I don't have to do anything with it. So now I'm going to plug in what I know, and I know that f prime is cosine. I don't know why I paused, I apologize. Multiplied by my g of x, which is 3x plus 9. And then I'm going to multiply by my g prime, which is just 3. So things are kind of all over the place. What is going on here? A is definitely not there. B is definitely not there. C and D. What is going on? Why does it say 3x plus 9 in the front and 3 over at the end? You want to make sure that this guy kind of stays close to each other. You can rewrite it how you would like to, but it's a little more weird. Just go ahead and take a 3x plus 9 and put that out in the front, especially when it's right next to a cosine, because you want to make sure that those are staying together and everything's being multiplied. So by default, you can rewrite it however you would like. By default, C and D are both correct. However, D is the better answer only because of the way that it's written. Nothing else. You want to keep them a little bit nicer when you're writing them out, but they're technically both correct. All right? So remember, when you're multiplying anything, you have that commutative property where you can just start moving things around and rewrite them however you'd like. I'm going with D only because it's a nicer look, and I wrote them both the same just so we could talk about the commutative property. All right, we have problem 8. Problem 8 says, a high school surveyed 1,000 students. The students were asked how many hours they spend watching TV a week and whether they watch cable or use a streaming service, Netflix, YouTube, Hulu, etc. The results are shown below. What percentage of the students watch TV via streaming service? Okay, so let's figure out what the problem is telling us. We know that we have 100 students. I meant 1,000 students. I apologize. It's 1,000 students. We know that they're watching TV via cable or streaming service. And we are looking over here and we're noticing that the amount of hours that these students watch TV are provided to us. And underneath there, we have these numbers. The question is asking us what percentage of the students watch TV via a streaming service. Were they specific on the time frame that these students watch TV? No, they were not. There was no specification on the amount of time the students watched a streaming service. They're just telling us a streaming service. So that tells us that when we're solving the problem, it means all of the students that use a streaming service have to be included. In order to do that, we have to look more at what that total would be. So based on what we know that we have 156 students watch a streaming service from 0 to 1 hours, and it's still a streaming service, just like the 2 to 3 hours of 264 students and the 337 students for the 3+ hours. So in order to figure out the total amount of students that watched a streaming service, we have to figure out the total of students that watched a streaming service across the board. The time here doesn't matter. All right, so let's go ahead and add them all together. 156 plus 264 plus 337. All right, and that gives a lovely total of 757 students. I'm going to put SS for streaming services. All right, so we know that 757 students watched the streaming service. But how do we get a percentage? That's a total number. That's a whole number. How do we get a percentage? Well, if I'm thinking about it, I know that my end result can be a percentage if before that I have a decimal and before that I have a fraction. So if I start with a fraction, I can turn that into a decimal and take my decimal and turn that into a percentage. And that's how I'm going to be able to solve this percentage, right? I need to figure out the percentage. So I need to start with my fraction, put it into a decimal to get to the percentage. The time doesn't matter in this case because they didn't say specifically students that watched the streaming service for 2 to 3 hours or students that watched the streaming service for 3+ hours. They're including all streaming service hours, no matter how many hours you watched it, it's a part of the streaming service, and that's what we're looking at. So in order to make my fraction, I know that I need the part or my desired over my total, right? So the part or desired that I'm looking for is the students that watch streaming services. Does not matter the amount of time they watched it, just as long as they watched a streaming service. So that gave me 757. And my total is the lovely 1,000 that they gave me in the beginning. If for whatever reason they did not provide you with 1,000, you have to add all 6 numbers up to get your total. And in this case, if you do, you get 1,000. That's how I know that it works. So now I'm going to take my fraction and put it into my calculator. My calculator tells me that it's going to be 0.757. To get that into a percentage, I multiply by 100, and that's 75.7%. But remember, they told us, oh, they didn't tell us to round, but our answer choices are all rounded. So we're actually going to round up because of the 7, and we're going to get 76%. So the time doesn't matter. I'm going to say it one more time. The time doesn't matter in this case because they didn't specifically say that it was streaming services. What percentage of the students watch TV via streaming services for 2 to 3 hours or 0 to 1 hours or 3+ hours? They weren't specific, so we have to include everybody. No, in this case, increase minus decrease, we do not need to do any of that. It's simply just making sure that we take the numbers that we need to put them into a fraction to get to that percentage that we're looking for.
All right, problem 9. It says a high school surveyed 1,000 students, very similar to the problem before. And the students were asked how many hours they spend watching TV a week and whether they watch cable or use a streaming service, Netflix, YouTube, Hulu, etc. And the results are shown below. So the table is exactly the same as the one before. Now the question has changed. What percentage of the students watch TV for 2 to 3 hours? Watch TV. Were they specific on if it was cable or streaming services, or does TV mean cable? Can somebody help me out here? So from the problem, we know that watching TV is either or both cable and streaming services. So obviously the student couldn't have done both cable and streaming services, but in this case, when they're asking us our question, we have to include both scenarios. We have to include both the cable and the streaming services. So here, they're very specific about our time. So time matters, right? And they're looking for time based on 2 to 3 hours. And because they said watch TV and not specifically cable or streaming services, we're looking at both of these numbers, right? So they're asking us for another percentage of the students that watch TV for 2 to 3 hours. So here we have to add the total of 105 and 264. And that gives us a lovely total of, I think, 369. Remember, this is the amount of students. So right now we have 369 students that watch television for 2 to 3 hours. Based on that, we're going to go back to that thought process that we had earlier. In order to get a percentage, I know that I can get a decimal. And before the decimal, I have to start with a fraction. And I know that my fraction is going to be my part or desired over my total. Yes, you are adding the cable, which is 105 students, and the streaming service, which is 264. And that gives us the total students that watch television for 2 to 3 hours of 369 students. And I have my plus sign right here. Okay, so the part or desire that we're looking for is the amount of students that watch TV for 2 to 3 hours, and we have our total. That's 369. We know the overall total of students that were surveyed is 1,000. We're going to go ahead and put that into our calculators, and our calculator will tell us that it's 0.369. Remember, if we multiply that by 100, we will get the percentage, and the percentage is 36.9%. Okay, well, 36.9 doesn't seem to be one of those answer choices. So we look at the decimal after, we look at the place number after the decimal, that's a 9. So that tells us we're going to round up the 6, and we're going to get 37%. All right, 37% because we have to round up. Any other questions? All right, I am actually out of questions today. We ran through them pretty quickly. Does anybody have any questions for me before I go? All right, as always, I want to thank everyone for being here today. Anybody has any questions, the Learning Liaisons email is always open. Our website's always there for anyone that needs help. We do, aside from our Math Wednesdays, have private tutoring. We also have our lovely boot camps that people love to work through. It is a video-based and worksheet-based program and course to help you through things. So thank you again for being here, and check us out if you want some private tutoring. But the Learning Liaison, we're here to help. Have a great night, everyone.